Hello everyone, welcome to Code Decode. So in this video, we are going to learn how to reverse a linked list. So before we actually dive straight into how to reverse a linked list, we need to understand what a linked list actually is. Linked list is a linear data structure with a bunch of nodes which are connected to each other as we see over here. So this is one node, this is another node, and this is another node. So each node consists of data and the address of the next node. So in this particular example, we have the data and the next represents the address of the next node. So unlike arrays in linked list, we can insert and delete data at any point of time. For example, if I want to add a node between this particular node and this particular node, I can totally do so. Now that we know what a linked list actually is, let's see how to reverse a linked list. Over here, the problem statement states that reverse a linked list, do it in place and in one pass. The keyword over here being in place and in one pass. In one pass, which means we need to complete this in O of n complexity. If you don't know what time complexity and space complexity are, please do let me know. I'll make a video regarding the same. If given an example, a linked list to be precise, 1 is connected to 2, 2 is connected to 3, 3 is connected to 4, and 4 is connected to 5, and the 5 is connected to null. So we need to reverse this particular linked list so that it returns 5, 4, 3, 2, 1 and null. So how do we do this? In general, while solving problems, we need to first understand and come up with a brute force solution, and then eventually we can build it up towards the optimal approach. So what's the brute force approach for this particular problem? Let's see. So the first approach which comes to my mind is to use a stack data structure. Why are we using a stack data structure? Stack data structure is a last in first out data structure. What do we mean by last in first out data structure? In a stack, the first element which we are going to insert into the stack will be the last element which we are going to take out of the stack. It's alright if you do not understand the definition. Let me explain it to you more clearly. Right now what we are going to do is we are going to traverse through the entire linked list, and then once we traverse through the entire linked list, we are going to take each element, it is each node out of the linked list, and we are going to push it into the stack. So node 1, so I'm going to insert it into my stack, and then followed by node 2, node 3, node 4, and node 5 till we reach the end of the stack. Once we reach the end of the stack, there's nothing else to be pushed into the stack, right? Our stack is filled with our nodes from the linked list. So next what we are going to do in order to reverse our linked list is that we are going to pop each and every node from the stack. What do I mean by pop? We are going to take out each element from the stack. Since stack is a last in first out data structure, the last element which I have inserted, which is 5, will be the first one to get out. Since 5 is the last element which we have pushed into our stack, it will be the first one we are going to push out from the stack, followed by 4, and then followed by 3, 2, 1. As we can see, our linked list has been reversed. Let's just code it out a little bit and understand it in more depth. Alright, so over here we have a class named list node, which is essentially our node, which consists of a data value and the address of the next node. In order to inculcate the stack data structure into our code, let's go ahead and create our stack data structure. So over here, A is our head variable. let's just go ahead and assign it to a temporary node named temp. Step is to traverse through the entire linked list and push all the elements into the stack data structure. Let's do it right away. While my temp, which at this moment is our head, is not equal to null, let's go ahead and push it into a stack. st.push temp.value. Okay, we have pushed our head into the stack, which is at this moment is 1. We need to go to 2 as well. So temp is equal to temp.next. I hope it's clear right now why we have used the temp variable earlier. Okay. Now all the elements of our linked list are pushed into the stack. So the next step is to retrieve all the elements from a stack. Let's do it. Before doing that, let's go ahead and assign our head node to the temporary variable. We are going to assign the reverse stack elements to each node of our linked list. While my temp is not equal to null, at this moment it is our head element. Temp dot value is equal to stack dot pop. We've retrieved the element number 5 at this moment and we need to move forward, so we are going to type in temp is equal to temp dot next. So in this particular node, while our temp is not equal to null, for example temp dot value is going to be 1, we are assigning it stack dot pop, which is going to be 5. So finally we are going to return our head element, which is the reverse linked list. Let's run it once. Great, but this is not our optimal solution. This is just our brute force solution. The reason being, we have used O of n time complexity, which is great, but at the same time we have used O of n space complexity, which is not at all great. We have to think of a solution wherein we do not use O of n space complexity. Let's see how we can do so. Let's go ahead and try in place traversal this time for better optimal approach. Before doing that, I'm going to create few tree nodes or variables which are going to store the values of our current element, the element after that, which is going to be our next variable, and the element which is before our current element, which is going to be our previous element. So we are traversing through the entire linked list. And then my current variable is assigned to head. In this particular case, it is A. And my previous variable is assigned to null, and the next variable is assigned to null. Now, coming to the actual algorithm, while my current element is not equal to null, which means if it is equal to null, we are at the end of the linked list. So my next variable is obviously the one after the current variable, which is current dot next. And my current variables next is connected to the previous element. My previous variable is assigned to current and my current variable is assigned to next. Let me explain this in detail. Right now my current variable is 1. My next variable is current dot next, which is 2. So let me write it down. It's 2. Current dot next is equal to previous. This is a crucial step in our reversal of the process, because we are connecting our current elements next to our previous element, which means current element is 1 and I am pointing it towards null. My current dot next is equal to null, and my previous element I am going to assign it to my current element, which is going to be 1, and my current element will be next, which is 2. So now our current element is 2. The one next to 2 is 3. So we are going to write 3. Our current dot next is equal to previous. At this moment our previous is 1. So our current, which is 2, 2's next is going to be 1. Previous is going to be the current element, which is going to be 2, and the current element is going to be the next one, which is going to be 3. Again, right now our current element is 3. Our next element will be 4. Our current dot next is going to be previous, which is 3's next is going to be 2. Alright, 3 is connected to 2, 2 is connected to 1, and 1 is connected to null. Our previous element will be our current element, which is going to be 3, and our current element will be the next element, which is going to be 4. Again, current element is still not null, so our next element is going to be current dot next, which is going to be 5, and our current dot next is equal to previous, which means our 4 is connected to 3. Previous is going to be the current element, which is 4, and our current element is going to be 5. Let's be clear, over here at this moment we are towards the end of the linked list. So next is going to be the current dot next, which at this moment is null. Current dot next, which is 5's next, is going to be previous. We are to 4 connected to 5 is connected to 4. Our previous element will be the current element, which is 5, and our current element will be null. We have come towards the end of the linked list, so we'll get out of the while loop. Let me go ahead and create a node named current, which is going to store the current element of our linked list. In this particular case, it is going to be A, which is the head of our linked list. Let's also create another list node named previous, which will be storing the previous value of our current element. I'm assigning it null. I'm also creating another list node named next, which will let us know the next value of our current element, and right now I'm assigning it value null. The crucial step in this process is to traverse through this entire linked list. So in order to traverse through this entire linked list, we are going to take the help of the while loop. While my current element is not equal to null, if it is equal to null, we are at the end of the linked list, so we do not need to traverse anymore. My next is equal to current's next. Current values next is connected to the previous variable. My previous variable, I will assign it the current variable, and my current element will be next. So this is the main code wherein we are performing the reversal of the linked list. Let's go ahead and return the previous variable. The previous variable at this moment contains 5, which is the head of the current newly formed linked list. Let's go ahead and run this. Great. This is the iterative approach to solve this problem. This is the optimal solution, but there is another optimal solution as well, wherein we use the recursive approach. Do let me know if you are interested in the same. If you did like this video, please don't forget to like this video, subscribe to my channel, and share it with your friends. Thank you. Bye.